Are continuing in 11.3, talking about our data distributions. Okay. Yesterday we kind of reviewed a little bit of mean. We talked about our 5-number summary, which I think was review, maybe not. And then we also talked about standard deviation a little bit. Okay. And so we are going to look at how we can use this data to compare. Okay. So to compare different types of distributions, you can look at the shape, the center, and the spread of the distributions. The standard deviation, range, and interquartile range are 3 measures of the spread. So when we talk about measures of the center, we talk about our mean, median, mode. We talk about measures of the spread, so how either compacted is it or spread out is it. Those are our standard deviation, range, and interquartile range. We talked about standard deviation yesterday. You have the iPad to figure that. Okay. Range. You guys have done range before. Range is when you're doing the highest minus the lowest value, subtracting your 2 endpoints. So how far apart are those? And then interquartile range. I don't know if you've done this or not, but interquartile range is the difference between the 3rd quartile and 1st quartiles. So if you recall yesterday when we found these, so like on this last example we did, our range would be doing 35 minus 3, the max minus the min. Whereas the interquartile range is doing 33 minus 12. So it's the difference between the 1st and 3rd quartiles. Okay. With that information, okay, we can help determine what kind of distribution we have. So a skewed distribution is one with a shape that is stretched out in either the positive or negative direction. So as you look at the pictures here, we have the left and the right are skewed. Okay, it's not a nice, neat, symmetric curve. Okay, it is pulled one way or the other. A symmetrical distribution has a shape that, when reflected across the mean, the display is roughly the same. So from that mean, it's symmetric on both sides. Okay, as you look at this, in a symmetric distribution, the mean, median, and mode are all about the same. So right here, there's an example of symmetric. Mean, median, mode are all right there about the same number values. Maybe not exact, but very, very close. And if it's a symmetric distribution, where they're all about the same, you're going to use the mean and the standard deviation to describe the center and the spread of the data. Okay, so when you're asked, okay, what should we use? If they're all about the same, we're going to use mean and standard deviation. If it's a skewed distribution, okay, so where you have more values one way or the other than the mean, if it's a skewed, where the mean is more affected than the median, you're going to use the median and interquartile range. And that's going to be important in what we're doing in the rest of this lesson. You're going to use those 2 pieces to describe the center and the spread. And we're going to practice that in several of our next few examples. So, let's look at the next example. The question is, what measures of center and spread would you use for the following data? So when I ask what measures of center and spread, basically you're either using the mean and the standard deviation together, or you're using the median and the interquartile range. Okay, those are kind of your options. Now, in order to decide which set to use, we kind of need to look and see what the data is doing. Okay, easiest way to do that is to find mean, median, mode. Okay, are they all about the same? Are there some differences? So that's what we're going to start off doing, is finding our mean, median, and mode here. So what are you doing for mean? You tell me. Okay. So mean, we're going to add them all up, divide by the number of numbers. What'd you say it adds to be? 399? And he says there's 15 numbers, is that right? Maybe. We got a chance to count. Okay, so it should add to be 399 according to my notes, I agree. divided by 15. What is 399 divided by 15? What do you guys get? Is it 26.6 even? Okay. I didn't know if I had a rounded answer here or what I have on my paper. Okay, there's your mean. Good deal. What about median?
29.
And how do we know that's 29? Count in. So first of all, do recall numbers need to be in order. I was nice here, or I was just trying to save us time. Numbers are already in order. Will they always be given to you in order? No. Okay. I was trying to be nice here. Saves me time here. So if there's 15, it's going to be counting into the 8th number from either side. So I'm going with, it's that 29? Okay. That is your median. And then one that we did not exclusively talk about yesterday, the mode. What's the mode? Okay, the number that repeats the most, which in this case, we got 333s, is that the most? Okay, 33. So I don't think that's anyplace else in the note, so if you need to write down a note to yourself, number that repeats the most, in case you have long since forgotten how to find mode. It's the easy one, is always my thought, especially when they're given to us in order. Okay, as we look at this, mean, median, mode. And I know you guys don't have anything to judge against because it's our first example, but are those all about the same, or are there some differences? And this does fall into the category of there are some differences. Okay, so if you're not sure what it, they need to be a little more similar than that for us to say that they are all about the same. So there are some differences. Another thing we can look at here is if I look at the median. Okay, here's my median at 29. As I look at these data values, as I look from 29 up to 37, that's what, a difference of 8 or so? Okay, whereas if I look at the difference from 29 down to 10, those are more spread out that way, aren't they? Because that goes from 29 to 10 is a difference of 19. So I can see that these numbers are going to be spread out more. Okay, if I have to draw based on a curve like what we see up above, this is going to be more of a skewed left example, because from the center, there's going to be more numbers to the left. Okay, there's going to be more numbers to the left over there, and so that's going to be more of a skewed left. And if you look at where mean versus median versus mode are, this matches up too. Okay, and so this is a situation where the data is going to be skewed left. Mean, median, mode, I'm going to say they vary. They're not all the same. And if you recall, what did that say? In a skewed distribution, what are we going to have to find? Median and interquartile range is what we're going to use to describe the center and spread of data. Okay? So let me write down some information. So first of all, so you have this. I'm going to write down that the data is skewed left. And when we know the data is skewed left, we know that partially, or skewed one way or the other, because the mean, median, and mode vary. They are not all about the same. There are differences, okay? Based on that information, in order to answer the question, what measures in center of spread would you use? Median and interquartile range. And we actually have to find those. Okay, so based on the fact they're different, they're skewed, we need to find our median and interquartile range. Give you a moment to catch up writing that. What do we already know here? Our median is 29. So that's saying that the best description of this data for the center is the median as 29. Interquartile range. What do I have to know in order to find the interquartile range? What do we have to know? Sorry, I heard two people say things at the same time and I could not. Okay, we're going to have to know those first and third quartiles, aren't we? Because to do your interquartile range, you're going to do the third quartile minus the first quartile. Right now, I don't know my quartiles. Okay? Do you remember how we did this yesterday? In this case, the median is a middle value, yes? The median is the middle. It's not the lower half. It's not the upper half. It's the middle. So basically, block out the median. Use everything to the left. So basically, we're looking from 10 to that first 29. What's the middle of that data? What'd you say it was? 21? Okay. So this is, if you recall from yesterday, I'm going to call it Q1. It's my first quartile, right? Lower quartile. And then, again, my median is 29. It's not a lower and it's not upper. So from the upper quartile, your third quartile, you look from the 30 to 37. What's my third quartile? Specifically the middle 33? Okay. Not that it matters, I guess, technically. It's 33. But this is our third quartile. I'm abbreviating as Q3. So, interquartile range. How are we going to do interquartile range? Yeah. You're going to do 33 minus 21, because that was third quartile minus first quartile. And what is 33 minus 21? It is 12. Okay? So look at your data. Look and decide. You know, is this skewed? Is it symmetric? Skewed told me to use median and interquartile range. Okay, so that was the key. Because my data was skewed, the mean, median, and mode varied, that's how I knew to use my median and my interquartile range. Okay, so a best description of this data is your center as 29 and the spread as 12.
So if you have to, it doesn't matter which, if it's skewed left or skewed right, can you still use the same one?
Skewed left or skewed right, direction of skew is not going to matter. It's still going to be median and interquartile range. The other option is if it's symmetric. Okay, that's when we go the other way. Okay, questions here? Okay, let's try another one. I think, do I have this on another page? I do. Okay, what are the better measures of center and spread of the following data sets? So, in order to decide, we need to do a quick run through of mean, median, and mode. Okay. Okay, I'm not going to spend a bunch of time on this. I'm assuming everyone can find the mean, right?
Yep.
So if you've got it, great. If not, keep working on it, but not a huge concern here. Mean, what are we adding up to get? Okay, we add up to get 696. I'm being told there's 12 numbers here. 696 divided by 12 is? 58? Is it 58 exactly?
Yes.
Okay. So we have 58 there. Median. What do we say? We had 15 or 12 numbers, so you're going to count in 6. So if we count in 6 from either way, my median is going to be between 58 and 58, and the number between 58 and 58 is 58. Okay. What about mode?
So it'd be 58 because there's 59 and 57.
But modes were allowed to have more than one. So modes we don't average. We're allowed to have more than one. So what do we notice with modes? It's number that repeats the most. And we have 357s and 359s. So that means we have 2 modes because 57 and 59 repeat equally the most. Okay? With that information, what would you guess about this data? Okay. My mean and median are the same. My modes are on either side of that. Does that make everything about the same here? Yeah, I would say so. So in this case, if we were to graph this as a distribution like what you saw there, it would be the symmetric type curve. Okay? And that's, A. The other thing you can look at here is 58. 58 is about equal from 55 and 61. So that helps us to have an idea that it is going to be symmetric. So, piece of information I'm going to write it this time. I'm going to say data appears symmetric. And one of the reasons we know that is because the mean, median, and mode are all about the same, similar, however you want to express that. So mean, median, and mode, all similar. In this case, what am I going to say? Okay, because we're looking at a symmetric distribution, then we are going to use the mean and the standard deviation. Okay, what do we know about mean? We already have that? Mean we found on the initial step here, yes. So my mean, remember from yesterday, I'm going to throw in again, X bar is 58. How do we do standard deviation? That was officially on your iPad, yes? So, as a quick review, and if you have the iPad, you can pull it up. If not, I'm trying to be quick today, so I'm not spending a bunch of time. But in case you've slept since yesterday, hopefully you have. Okay, remember you go into Microsoft Excel. It was pointed out to me, I had you guys go into more functions yesterday, yes? Once, and in more functions, it was under statistical. And then you had to scroll down to stdev.p, standard deviation.p. And you can click that. It was also pointed out to me yesterday, later on, once you found it, it's over here in recent. So most of you would have found it yesterday. It's over here in recent. And you can just pull it up right there. It puts you in a box. type your numbers. It was a list with commas, right? So 55, 55, 57, 57, 57, 58, 58, 359s, 261s. When you get done, hit enter. Is that right? Okay, yeah, that is what I have on my notes. Okay, so again, check with me, check for classmates for help if you're not sure what you're doing there. I have mine rounded to 2 decimal places. I have a feeling maybe that's what the book or the answer key was doing. Okay, if we round this 1.87083 to 2 decimal places, it's approximately 1.87. Recall yesterday we talked about standard deviation can be expressed using sigma. So this is sigma, and that is a way to denote standard deviation. Good review, good refresher. I'm not here tomorrow to review with you how to find standard deviation, okay? So rely on each other. Okay. One more real quick. Some of you have probably started knowing how you guys run. Okay, in order to decide which measure of center and spread, first thing you're going to do is find your mean, median, and mode. Okay, what's going on with my mean? Okay, I'm hearing the total is 1,690. 12 values again. So they add to be 1,690. We divide by 12 and we get. Okay. 140.83, and I have the, is the 3 repeating? Is that what's repeating? Okay. What about median? Okay, there's 12 numbers, so you're counting in 6 each way. And it does indeed end up between 130 and 140. So common sense to me says the middle of 130 and 140 is 135. However, reminder, if it's not common sense or if it's not as obvious of a one, 130 plus 140 and divide that by 2. We get 135. What about a mode? Looks like we've got what, 3 110s? Okay. What would you say about this data? Is it symmetric or skewed? Okay. My mean, median, and mode are varying, aren't they? They're not very similar. If I look at my median of 135 down to 10, as opposed to 135 up to 190, there's definitely a difference in gap, isn't there? Now, in this case, I have more of my data values where they're skewed more to the right, is what I would say on this one, because they're going to be more spread out on the right. Okay? So, now, does it matter which way it's skewed for this purpose? No. The data is skewed. That's what matters. Okay? So the data is skewed, and the other indicator is because the mean, median, and mode all vary. Okay? So the skew and the vary are your 2 clues there. When my data is skewed and those vary, what measure of center and spread am I using? Okay, we're going to have to talk median, and we're going to have to talk interquartile range. Okay. When you get to this point, you always have the measure of center already, don't we? We already have the mean or median. We already found that. What was my median? 135. Okay, what about interquartile range? We've got to find our quartiles, right? Median, it's not in the list. 135 is not in the list. So we're going to use all the numbers on the lower end. So we're going to use 110 to 130. What's the middle there, did you say? Okay. Right there is my Q1, my first quartile. In between 110 and 120 is 115. You don't believe me? Add and divide by 2, yes? What about in the top half? Okay, so top half, again, we just don't use a median, use all numbers above it. We've got 6 numbers. In between 160 and 170 would be 165. I didn't write it down, but. So, we're doing what? 165 minus 115, which is 50. We did that because we did third quartile minus first quartile. As I said, you often see me say Q3 minus Q1. Okay. If I don't get through all the notes, this is similar to what we'll also be talking at the end of the notes. We kind of repeat it a little bit, so that will be good. You've got the basic gist of what we're doing. Okay. Savas, it's going to vary sometimes. Okay, so you'll have to work with it and work with the data. Have a calculator. I was going to say have the iPad by your side, but you'll probably be doing the homework on the iPad, so the iPad should definitely be available if you need to do it. Use it for standard deviation. Okay. As we go, maybe, to the next page. This is more, okay, in the previous page, we were looking at the numbers, looking at the data. This is now more looking at the pictures. Okay, looking at, it's already set up as a graph. And are these following variables likely to have a normal distribution? Now, if we go back, okay, let me go back real quick to our pictures. Okay, normal distribution. When we talk normal distribution, okay, it has the symmetric shape. Mean, median, mode are all likely to be similar. Okay, it's not skewed where you have more data values pulled to the left or more data values pulled to the right, but this is normal. Okay, now we're going to look at some with pictures. We're going to look at some without pictures. So, are the following variables likely to have a normal distribution? So, A is the heights of all the people in a large group. Looks like it, yes. Okay. For one, how do we know? The shape. Does my shape in general, you can't get nitpicky here, but does my shape in general have that symmetric shape? It does. Okay. So, yes, this is one that's likely to be normally distributed. Think about the variable here. We're talking about the heights of all the people in a large group. What do we have? We have some short people, right? We have some tall people, yes. But on general, what are most people supposed to be? There's average, right? So you've kind of got the shorter people, the taller people, but in general, they're saying, okay, there's going to be a big chunk of people that are at the average category. Okay, so you can write, I just have yes, normally distributed written here. If you want to write more of an explanation, go for it. Okay. But that's the idea, that your tail ends of the data are lesser, big chunk of data is in the middle. Okay, B. B gives us a graph, and it's the probability of landing on each of 8 equal parts of a spinner. Is this likely to be normally distributed? No? Why not?
It's just all probability.
Okay, it's all probability. If we're talking about probability of landing on 8 equal parts of a spinner, what is technically true? You spin a spinner and there's 8 equal parts. You have equal probability of landing on each 8 parts, yes? Is that going to have that normal distribution, that symmetric curve? I mean, it could happen to, but is it expected? No. Officially, this should all be, I mean, if it's exact probability, it's all level. Now, it's probability, so does that all happen? No. So here, if you watch that shape, it's up, it's down, it's up, it's down, it's up, it's down. It's probability, okay? It's not going to go with normal distribution. So, no, not likely to have a normal distribution. I put that each probability has an equal chance of occurring. So, no. Each probability has an equal chance of occurring. Okay. Looking at the picture can help you, but also thinking about the scenario. I think the scenario makes a big difference there too. Okay, look at C. The scores on an easy test. What do you expect about the scores on an easy test? Okay, they should be higher, yes? Like, this test I just gave you guys last time with all the notes. I had not a single F amongst all 3 classes, folks. That's unheard of. Okay.
Do that more often.
Now, the idea here, okay, scores on easy tests, what's going to happen? It's going to be likely to be something like that, right? Where you've got fewer at the left, you've got more at the right. Okay, this is not symmetric. It's not a normal distribution. We never want normal distribution on a test, because that would put everybody like right in the middle. And, you know, I prefer the grades be,
Slightly skewed.
you know, skewed. Now, this is because there's more pulled out to the left. This is what we call skewed left. Okay, it's backwards in my mind, so I always have to pause and think. This is called skewed left. Okay. Learn the vocabulary, because my brain works backwards, but it's skewed left because these numbers are spread out and they pull to the left. Okay, so it's not where the bulk is. We don't say it's skewed the other way. So I have no, the scores would likely be skewed left. And even if we didn't have this graph, could you come up with that? I think so. So I'm going to say no, the scores would likely be skewed left. Okay. D, number of children in a family. Well, we have a picture to look at here, yes?
Skewed, right?
This one, the picture is definitely showing skewed right, isn't it? Now, the idea is, could you come up with that on your own without the picture? I mean, I would like to think, you know, how likely it is for 6, 7, 8, 9, 10 kids. That's less likely, isn't it? I'm not saying it doesn't happen, am I? So if anyone's out there saying, but I didn't say it doesn't happen. But if you think about the average of your peers, do most of your peers have 6, 7, 8, 9, 10 siblings? Okay. Now, I know in this day and age, especially, we get into the whole step situation and all of that, but, there's now, if you think about how many people have 0 kids, I wouldn't have expected it to be that high in comparison, but maybe. Regardless, more families are definitely going to have fewer than more in respect to the really big numbers. So, no, definitely skewed right. More families have fewer children and thus skewed right. Okay, 2 scenarios real quick without a graph to look at. I know it makes it a little bit more difficult. You have to, think carefully here. Is each situation likely to be normally distributed? Weight of individuals in a population. Do we have an average in the middle, most likely? You have some that weigh a little, you have some that weigh a lot, but you have an average in the middle, don't you? Okay, so this is a situation where, yes, this is most likely normally distributed. The scores on a difficult test. Okay, is this going to be opposite of scores on an easy test? Okay, scores on a difficult test, there's going to be a few numbers to the right. There's going to be more to the left, aren't they? So, no. Scores likely skewed right. Okay. We technically have 2 more examples in notes. Okay. As you look at these 2 examples on the back, I feel like they're kind of a summary of what we've done. Okay. So look at them with me real quick. Obviously, we don't have time to work through them at this point today. How would you classify the following data set? Describe the shape of the distribution and the center and spread of the data. Okay. Similar to what we kicked off today with. Okay, there's a list of numbers. Okay, in order to be able to figure out how it's shaped, you're going to have to look at the mean, median, and mode. Yes? So look at your mean, median, and mode. And then based on, okay, are they all similar? And it's going to be symmetric. And if it's symmetric and all similar, and we would call that a normal distribution. Okay, we added that vocabulary here. Which measure of center and spread are you going to use if it's symmetric in a normal distribution? That's going to go back to the mean and standard deviation. Okay? If they aren't all the same, the data is bunched one way or the other and skewed left or right, then we will talk about using median and interquartile range. Okay? So those examples really kind of overlap with what we've already talked about. What I think I will do is I will probably leave you in Schoology a video and or picture of the notes. So you can fill it in as you please. Okay, I'll probably leave a video. I may leave a picture of the notes as well. Tomorrow, your job, finish up those 2 examples if you want. I'm not sure if they're 100% necessary because they are very similar, but they'd be good to have. Finish up those and then Savas 11.3. Now, the notes I will definitely have available on Schoology later today. So if you want to get that knocked out, you will definitely be able to do that. Savas I will open up either tonight or tomorrow morning. Okay? I'm going to get back in there and look and try and remember. I want to say it was like 14, 15 problems. So I was going to look at, how big the problems are and what I want to do there. Be on your best behavior tomorrow, yes? Get work done. Have an iPad charged. There's only so much room in my class, and you goof around when you're back there. So have an iPad charged and ready to use, okay?
These are stuff.
Mr. Rainey.